This lesson we're going to talk about applications with right triangle trigonometry. So here, this problem is asking you to find two informations. The first one is going to be the height of the building. The other one will be the length of the letter. The information given is going to be the letter is leaning against the building and forms angle of 72 degrees. So let's say we have a building and I'm going to put window so that you can see this is the building, right? And we're going to put letter against the building from the ground, and that angle, it's a 72 degrees. And also it said that the distance from the letter to the building is going to be 6 feet. And they're asking you to find the heights of the building and then the length of the letter. Let's do B, right? A, B. So in order to find A, we're going to use tangent 72 degrees equals to A over 6 feet, right? In order to solve for A, you're going to multiply both sides by 6. So A is equal to 6 times tangent 72 degrees. And you can get tangent 72 degrees from the calculator. And when you multiply that by 6, you will get somewhere close to 18.47 feet. So that's going to be height of the building. And B, if we wanted to find the length of the letter, you're going to use this time cosine, so you can use the one length that it's given, 6 feet, right? So it will be cosine 72 degrees is going to be 6 over B. In order to solve for B, let's multiply B on both sides first. So you will have B times cosine 72 degrees equals to 6, and divide both sides by cosine 72 degrees. You will get your length of the letter, which is going to be 19.42 feet. So you get those two answers for that problem. This next example is asking to find the height of the kite to the nearest foot. So your kite is right here. What do we know from the problem? You can also read the problem here. It says that kite is holding from 4 feet above the ground. So this is the 4 feet. The angle from the horizontal to the kite is 42 degrees. The length of the string is 120 feet. So how do we find the height? Well, the height from the ground should be A plus. So this is A, right? Plus 4 feet. And we need to find the A first. How do we find A? Because the hypotenuse is given, we can use the sign to find it. So we'll say sine 42 degrees equals to A over 120 feet. In order to find the A, you're going to multiply both sides by 120. So you get 120 times sine 42 degrees. And when you plug in that into the calculator, it gives you close to, because we wanted to figure out nearest the whole number, it will be close to 80 feet. And if we wanted to find, that's just a length, right? We wanted to find the height of the kite, the whole thing is going to be x. So your x is going to be 80 plus 4 feet from the ground. It gives you 84 feet. Before we do the next two example, we wanted to go over and make sure we know how to use the bearing. So let's say if we wanted to show this location right here using the bearing, we're going to always use the vertical line as the steady initial, right? Which is going to be north or either south. So this point right here is going to give you angle from the north 42 degrees. So it will be north 42 toward which directions? East. So it will be north 42 east will be the way that you can call that directions. What about this point right here? This is going to be north 74 west. This point is going to be south 40 west. This point is going to be another south 69 degree east. So if we try this one right here, C, from O to C, this line right there, this is going to be using this angle. This is going to be initial side, so it will be 40 degree from south. South 40 degree toward, it will be east. Let's try one more. What about OB? This is OB right there, right? So this point, that's going to be north. What's the degree on this one? Well, let's see, this is going to be 118 minus 90. So 118 minus 90, which is 28 degree. So this is going to be 28. So you could say north 28 degree toward which directions? West. North 28 degree west is how you're going to call that point. What about C? This one is asking for A to O. A to O is from this point to this directions. So even though A and O is on the first quadrant, because it's going the other directions, we're going to use this angle right here, right? And how do we find this angle? Well, we can find this angle from, what's this angle given? That's going to be opposite of 22, so this is going to be 22 degree. And if we subtract 90 degree minus 22, we will get 68 degree. So this is going to be 68 degree from the south. So it will be south 68 west will be the bearing of that problems. So direction is also important, which direction we're going. Okay, so example 10. Let's say the plane leaves an airport heading south 32 degree west at 320 knots. Determine the number of nautical miles south and the number of nautical miles west that the plane traveled in 1.2 hours from the nearest nautical mile. So what I wanted to understand here is the picture and see if I can bring right triangles, right? So let's see, your airport is right here. You're traveling south 32 degree west. So if you draw the south and north, and your west is right there, right? And it's a 32 degree. Let's say this is 32 2 degree southwest. So that will be this directions, right? After 1.2 hour later, you are right here and your distance is 32 knots. But then problem is that they want you to use the nautical mile south and nautical mile west distance, right? So let's just change that unit before we do anything else. Your units 320 nautical miles times 1.2 hour will give you nautical mile. So it will be 384 nautical mile. So this distance from here to here, airport to the airplane is 384. And they want you to find the south of the nautical mile, so they want you to find this. And west, that mile. So if you draw this in right triangle with right angle on the bottom, right? You're going to have 32 here. Opposite of 32 will be B. And you have A here, and hypotenuse is 384. So if we wanted to find A, we are going to use cosine 32 degree. Should be equals to A over 384. Where, in order to find A, you're multiplying both sides by 384 times cosine 32 degree. Cosine 32 degree, we can find that from the calculator and multiply by 384. You will get close to your rounding, 326 nautical mile. So that's the distance of going to south, right? And then B, distance going to the west is going to be using sine. Sine of 32 degree equals to B over 384. So your B is going to be 384 times sine 32 degree. And when you multiply that, your value for B is going to be 203 nautical mile. Example 11. A boat leaves Marina heading north 52 degree east at 6 miles per hour. After 1 hour, the boats make a 90 degree counterclockwise turn to a new bearing of north 38 degree west. If the boat travel this new course for 2 hours, find the boat distance from the marina to nearest the tenth of the mile. That's the first question. The second question say to a tenth of degree, find the bearing request for the boat to return to the marina. And good thing about this problem, we have the picture given. So it said the first, the boat is leaving the marina, traveling north 52 degree east in this directions for 6 miles per hour. After that, it makes 90 degree turns going to north 38 degree west, right? So this is going to be 38 degree. From that point, you need to measure north 38 degree west, so will be 38 degree, and that give you 12 miles. So now both is right there. The first question is to find the distance, this distance right here, from the location of the new location of the boats to going back to marina distance, right? So how do we find that? Well, let's see if I can draw the this triangle on the side, so we don't touch all those measurements. That will be look like that. That's 90 degrees, and this is going to be 12 miles. And this is 6. Look like that's A, B, and M, right? And what are we looking for? A is hypotenuse. So with the triangle, right triangle, with two sides given, we should be able to find the length A easily using the Pythagorean theorems. So because we're looking for the longest length, we're going to add square of both sides, right? So it will be 6 square plus 12 square, which gives you square root of 36 plus 144. That's equals to square root of 180. And when you simplify square root of 180, you get 6 square root of 5, which is 13.4, close to. So let's say it's 13.4. Your A is 13.4. That was number 1. The second one is asking you to find your bearing going backward. So when it's a bearing going backward, you need to find the bearing of this directions like that, right? It means you need to know this angle. Because you have to say south, because it's going down, so it'll be south east directions, right? And we need to find this angle in order to get the proper bearing. And how do we find this angle? This angle is going to be vertical angle of this angle. So if we have the whole measurement of this triangle, if we know this angle, subtract this 52, that will give you your theta, right? So how do we find this angle then? We should be able to do that, let's see, 2 by tangent. I didn't want to use this measurement A because that was the measurement that we round, right? So if we wanted to use the exact value, we can use tangent. So tangent of theta, which is the x degree, is 12 over 6, which is 2, right? So tangent 2, tangent x is equals to 2. In order to find that x, the way that you're going to find that angle with the value given, you're going to use your inverse tangents. Tangent of -1 on the calculator functions to find the angle. And this will give you somewhere close to 63.4. So now this angle right here, so this angle right here is 63.4. When you subtract 52, you're going to get theta. And that's going to be 11.4. So your bearing is going to be south 11.4 degree east. Will be the bearing of this red directions, right? These directions.